Hello, everybody. Let's solve problem 1.38 together. So problem 1.38 has a dependent current source. So let's see what that means. And let's see how we can handle sources that are dependent when they're in our circuits. So this question says to determine Vy in our circuit, which is right here. So how should we do that? Let's walk through this. So first, we want to know Vy, and we can see that this current I is going to go through Vy, but we can see that current I depends on Vx. So what is Vx? Well, we see on this that this is defined as 1.2 amps. So this 1.2 amps must go through there. So Vx, right, would be given, so Vx is equal to IR, so 1.2 amps multiplied by 5 ohms. Okay, and so that's going to give us 6 volts, right? So we're going to have 6 volts now as Vx. So that Vx is equal to 6 volts. And we can see that this, right, it's going to go right into there. So now, and maybe to clarify, I'll say this is I1 and this is I1. So this I here is equal to 0.1 Vx. Okay, so this current that's going through this 2 ohm resistor that will give us the voltage drop Vy, it depends on this current I. So 0.1 times 6 volts, okay, is going to equal 6 times, right, 0.6 amps. And we could rewrite this, right, too, if we wanted. We could say that that was 600 milliamps if we felt like it. So what is that voltage Vy? Vy is equal to IR. And we know that this current is 0.6 amps. And the resistor here is 2 ohms. All right, so 0.6 times 2 is 1.2 volts. So you should get Vy is equal to 1.2 volts. So how did I solve this? Let's recap. We knew that we wanted to find Vy, a voltage drop. We saw that the current through Vy is going to come from a dependent source. So we said, how can we solve the dependent source? The dependent source depends on Vx, which is a voltage drop across this 5 ohm resistor that has a known amperage going through it. So we used Ohm's law to solve for Vx. We used Vx to solve for the current I, and we use the current I to solve for the voltage that drops across Vy. Hope this helps, and I'll see you all in the next video. Bye.